In March 2011, one of the largest earthquakes ever recorded shook Japan for nearly 6 minutes, creating a devastating tsunami that engulfed more than 200 miles of Japan's coastline. Nearly 16,000 people lost their lives. The tsunami also flooded the Fukushima Daiichi nuclear power plant, knocking out the plant's control systems and backup power. Overheating of the reactors led to explosions that spewed radioactive material into the atmosphere and the ocean. Efforts to cool the reactors with seawater caused even more radioactive material to wash into the Pacific Ocean. Fukushima was an unprecedented event, resulting in the largest accidental release of radioactivity into the ocean in history. To understand the impacts of Fukushima, we need to know more about living on our naturally radioactive planet. Most radioactive materials come from rocks in the Earth's crust. Some are produced by humans. Radiation is the energy released when unstable elements break down, emitting tiny, high-speed particles. This radiation is invisible, silent, tasteless, and odorless. The questions we need to ask about Fukushima are: how much radioactivity was released, and what are the risks to humans and to marine life? In large amounts, radioactivity can be deadly. Certain types can be dangerous even in small amounts, if swallowed or inhaled. We are constantly exposed to low levels of radioactivity. The air we breathe, the water we drink, the food we eat, all contain trace amounts of radioactive elements. These do little or no harm. In fact, radiation is used to treat cancer and other medical conditions. It saves lives. Scientists measure radioactivity in units of decay events per second. In the ocean, the most abundant radioactive element is potassium-40, a naturally occurring form of potassium. In 1,000 liters of seawater, about 260 gallons, there are about 12,000 decay events of potassium-40 every second. This is a big number, but is not thought to affect the health of humans or of marine life. Before Fukushima, the primary source of human-made radioactivity to the environment was the atmospheric testing of nuclear weapons, which peaked in the 1960s. Over time, that radioactivity has diminished, and today, on average, is thousands of times lower than the background radioactivity from natural sources. When Fukushima exploded, radioactive gases and particles escaped into the atmosphere. Most fell nearby on land and in the ocean. A smaller amount remained in the air, and within days circled the globe. In the ocean close to Fukushima, levels of cesium-137 and 134, two of the most abundant radioactive materials released, peaked at more than 50 million times above background levels. Fisheries in the vicinity of the plant were closed. Even when these levels decreased by thousands of times, fisheries near the plant were kept closed because of concerns about eating fish contaminated with radioactive materials. Tuna and other migratory fish close to Fukushima were exposed, but as they swam long distances through cleaner waters, most of the radioactive cesium was flushed out of their bodies. Debris washed out to sea by the tsunami was largely uncontaminated by radioactivity. Ocean currents are the main way radioactive materials from Fukushima are transported across the Pacific. As these materials spread, they become increasingly diluted and their concentrations decline, but they can still be detected. Scientists who have modeled the plume predict that radioactivity along the west coast of North America will increase, but will remain at levels that are not a threat to humans or to marine life. These predictions are being tested. Citizen scientists are collecting water samples, so researchers can make these measurements using sophisticated instruments. The results to date confirm that the cesium levels along the west coast of North America and Hawaii are only slightly higher than before Fukushima. Someone who swims in the ocean every day for a year would receive a dose from cesium hundreds or thousands of times lower than from a single dental x-ray or from one plane flight from Los Angeles to New York. At these low levels, fish and other seafood meet safety standards for human consumption. While radioactivity can be dangerous and should be closely monitored, we should remember that we will always be exposed to some, because we live on a radioactive planet.
Jag tror det blir bara 4 stycken.